right, so we're going to move on to the second half of this review, which really takes in the last 6 chapters, and just reminding you that the last 6 chapters will be 60% of the exam. So that's pretty important. And the way we're going to do this is we're going to, and there's a handout, and so for you that are viewing this, I can put that handout on I'll put the handout on Blackboard. If you want to go through and make your notes like this, you can. But we're going to go down, we're going to go through each chapter, and we're going to just deal with the certain organisms that are the most important from those chapters. You have in your workbook or your notes book that we made for you, you have an organization that goes by, the type of organism it is, gram-positive, oxide, gram-positive bacilli, fungi, etc., etc. What we're going to do now, we're going to go back to the chapters and we're going to talk about the organism in these chapters. So you see there's a couple different ways of looking at these organisms. I think the more ways you look at it, hopefully the easier it's going to be for you to remember. Okay, so we'll try this, see how it works. And if you that are here, if you have any questions, you can just stop me at any point, and then no problem, we'll entertain questions, okay, throughout. All right, so our first chapter was chapter 18, and that was the skin and the eyes. And we had, the order that I'm going with these organisms is, I think, pretty much the way they appeared in the book. So they're not going to be all the bacteria together, all the fungi together. And you actually have charts in the back of every one of these chapters that are organized more by fungi and bacteria. And so, so you do have charts, but at least with this, you're going to know the major ones to focus on. All right, so we had Staphylococcus aureus, we had Streptococcus Pyogenes, and as you'll notice, you're going to see these organisms pop up on a couple of different, in a couple of different body systems. Now, I'm not going to take the time to underline these, the scientific names versus the non-scientific names, but on the handout it is italicized for all the scientific names. So these two, we should remember as the reason that they were in chapter 18 was all the skin diseases that they cause. And so you want to go back and review that. The impetigo that they both cause, the scalded skin syndrome of the Staph aureus, they both cause cellulitis. Strep Pyogenes had the erysipelas. That's one of the things that it caused, and Staph aureus, the boils, and so there were a bunch of diseases. So you want to go through there and make sure that you remember which ones cause which. And so, like they both cause impetigo, but Staph aureus causes impetigo, and it also causes the scalded skin syndrome, but this one doesn't. So just make sure that you can distinguish them. And what are they? What's their gram stain reaction? Positive. Okay, they're positive. And what's their shape? Coccide. So I'm just going to put like a little abbreviation here on these GPC so that we'll remember that. Okay, then the next one on your list, and I'm going to abbreviate these because you have that list there, but it's trichophyton, epidermophyton, and microsporin. All right, and the we call these the dermatophytes, and they cause ringworm. Any one of these can cause ringworm. So that was the thing. And what kind of organism is Trichophyton, Epidermophyton, and Microsporum.
Fungi, I guess.
Fungi,
They cause
yeah. So there we go. So they are fungi. Okay, the next one is Clostridium perfringens. And it causes gas gangrene. And what kind of organism is that? I'm going to go get a red marker.
Gram-positive bacilli.
Right, gram-positive bacilli. So we're going to call it a GPB. GPB. Okay. All right. And so then we go, the next thing is the chicken pox virus. And as you see there on your list, it's not italicized, so that reminds us that it's not a scientific name. The main thing we learned about the chicken pox virus is we learned about, of course, what chicken pox is, but we also learned about the shingles and the vaccine for shingles, and the fact that if you're not immune to chicken pox, if you're around somebody with shingles, you can get the chicken pox from it. So, so that was the thing that was, I think, most important to us. And then we have another organism, and this one's going to pop up a lot, like the staph and strep did. And we have Haemophilus influenza. And what organism? What is it? As far, it's a bacteria, but what is it?
Gram-negative bacilli.
Right, gram-negative bacilli. And it was in the skin and eyes chapter because it causes conjunctivitis. It's not the only organism that causes that. We've learned of several. It's kind of I think of it though as the classic organism that causes pink eye, but it's not the only one that does that. Okay, and then we also have, and last here is Neisseria Gonorrhea. And it is in this chapter, this skin and eyes, because it causes a conjunctivitis in newborns that their mothers have gonorrhea. So that's why it's in this chapter. So what is it?
Is it gram-positive diplococci?
Right. And so I'm going to put gram-positive cocci here, GPC, or I mean gram-negative cocci.
Gram-negative.
GNC, gram-negative cocci. But we remember that it appears together as a diplococci. So it's a gram-negative diplococci. Okay? All right, so let's move on to the nervous system. All right, there are a lot of organisms in the nervous system that we studied. And so we'll start with this first one, which causes the most serious form of meningitis, and it's Neisseria meningitidis. And what's that gram-stain reaction for it?
Is that gram-negative cocci? Diplococci?
Right, and it's like the Neisseria gonorrhea. It's going to be in pairs, so gram-negative.
Are those the only two that are diplococci?
Yeah, they both are.
Are they the only two that are?
Oh, they are the only two. Okay, so when you see Neisseria, then you think gram-negative cocci, okay? And again, they do appear as a diplococci. Okay, the other thing is we had Cryptococcus Neoformans, and it causes meningitis, but generally the person has to be immunosuppressed. So we associated Cryptococcus Neoformans with AIDS patients, although they necessarily wouldn't be the only ones, but definitely have to have an immunosuppressant for this organism. And what is a Cryptococcus?
I don't know what the gram stain would be, but I guess it's cocci.
I know, that throws you off, doesn't it? Because it's not even a bacteria.
No?
No, it's not a bacteria. Fungus, okay, fungus. I'm going to try to conserve space here because I got a bunch of stuff to write here on this. Okay. All right, so then we have Listeria Monocytogenes. And Listeria Monocytogenes, it causes meningitis in adults and newborns. So we had it in 2 places in the chapter. And the other thing is that we know that it's associated with cold foods. It can be in dairy products. It can be in cold cut meats. There was a cantaloupe outbreak of Listeria. And so this organism, that's the thing that we associate it with. And so what is the Listeria?
Gram-positive bacilli.
Right, so that's a GPB, gram-positive bacilli. Okay, our next organism, and this is Escherichia Coli, and we learned that it causes meningitis in newborns, most likely in premature, but mainly just remember that it's with newborns. And that's one of the things, the reason why it's important to remember these gram stains is because you've got some that are causing the same things. And so in your questions, it will say the gram-negative bacilli that causes meningitis in newborns, and then that way you have to go down and pick out the one that has the gram stain reaction matches. So you don't want to forget the gram stain reaction because it's going to make a difference in whether you're going to be able to answer the question or not. And so what is the gram stain for and morphology for this?
Gram-negative bacilli.
Okay, gram-negative bacilli. Okay. All right, and then we have Streptococcus Agalactiae. And again, this is a meningitis, causes a meningitis in newborns. And what's the gram stain reaction in morphology?
Gram-positive cocci?
Right. And just keep in mind that once you know Streptococcus, that it's a gram-positive cocci, every organism that we have that's named Streptococcus is a gram-positive cocci.
Mm-hmm.
Okay, so that's a helpful thing for you to remember. Okay, and you see this is the big chapter. Now there's 2 organisms I'm going to put up together. There is Neisseria Gonorrhea, and there's another organism, Acanthamoeba, and we don't learn the genus name or the species name of it. We'll just say Acanthamoeba species. And these organisms, I'm going to write up the word, but they cause a meningoencephalitis. So that's an infection of both the meninges and the lining of the brain as well. And so what kind of organism is Acanthamoeba and Neisseria Gonorrhea?
Protozoa.
What's that?
Protozoa?
It is a protozoan, thank you.
Can you survive getting that disease?
Not very easily because of the extreme damage it does to the brain when it gets access to the brain. because it's actually in its motile feeding stage, and so it's actually destroying the brain. And again, they're very hard to treat. Protozoans, fungi are either one of them are very hard to treat. Okay, and I think they are both amoebas. I'm pretty sure they're both amoebas. Okay. All right. Rabies virus, I'm going to put it up here. You probably won't have a question that asks you what causes rabies. Okay, I think anybody can answer that, right? But the thing that we had on the open book, we talked about the vaccine for it. So be sure you remember the vaccine for that. Clostridium botulinum. And I'm going to go ahead and put up Clostridium tetani too. I don't think I asked you a question about tetani in that open book, except we had the DPT, which the tetanus is the T part of the DPT. Botulinum, Clostridium botulinum, it's in here, and it's also going to show up in the gastrointestinal tract because it's food poisoning, but its action on the body is to make the muscles go completely limp because the muscles go in complete relaxation. Tetanus is the exact opposite. It makes the muscles, it's a neurotoxin that makes the muscles go in complete spasm. So those two we kind of think about when we think about the nervous system. But botulinum, we also think about them when we are dealing with the gastrointestinal tract because it is a food poisoning as well. Okay. And down here, and what's the Clostridia? And they'll both be the same.
Gram-positive bacilli.
Okay, and I'm just going to put that between them. They're gram-positive bacilli. Okay, and then Haemophilus influenza shows up again, causes meningitis in 1 to 6 year olds. Not so much now because of the vaccine, and that was another thing that we learned about. And I'll wait here and put the gram state up at the end. Streptococcus Pneumoniae. And so these two are both bacteria. Streptococcus Pneumoniae causes a meningitis more often in adults. And so what's the gram-stain reaction of Haemophilus?
Gram-negative bacilli.
Right, so that's the gram-negative bacilli. And then strep pneumo, gram-positive cocci. And then we have one more here at the bottom, and that's Coccidioides Immitis. And what kind of organism, I misspelled that. It has, it goes again. You have it correct, so I'm not going to take the time, but what kind of organism is Coccidioides?
Fungus.
It's fungus. Okay, again, it's one of the dimorphic fungi, okay? So let's put that there so we remember that, dimorphic. And mainly in the southwest U.S., and it's in the dirt there in the southwest U.S., and anytime there's a disturbance, the spores come up and people inhale it, and then it causes a meningitis. Okay? All right, so on to the cardiovascular system. That's a lot simpler system as far as the organisms. There's not that many of them. Of course, you know, the definition of septicemia, we've talked about that. But just about any organism that gets entrance into the blood can result in some, you know, a bad infection in the blood. But there's a few that we discussed that have some specific types of diseases that are associated with them. One thing I want to mention, and we probably didn't use this term in class, but, and I'm using the Greek symbol for alpha there, alpha hemolytic streptococci. And these are the normal flora, and they mainly live in our mouth. And so these organisms can gain access to the blood just like through teeth cleaning or dental procedures. And we don't really worry about them so much except if they get into someone who has mitral valve prolapse or some kind of a valve defect. And so what is the, and then they cause, when they do that, they cause subacute endocarditis, or sometimes referred to as subacute bacterial endocarditis. So what would this organism be gram stain wise?
Gram-positive cocci?
Yes, gram-positive cocci. And it's not on your list there. But when we had it in our notes, we actually listed all of the different common ones. But you can just say alpha hemolytic strep, and you would be okay. I probably am not going to ask it from that standpoint. I'll probably ask the question from the standpoint of what we talked about, the person who has a valve defect and what you have to do to prevent this from happening and the name of the disease. Okay, and then we have Borrelia burgdorferi. And this is one of the ones where the gram stain is no valuable. It's not valuable. It is it's a spirilla, but we don't use the gram stain. And what's the disease that Borrelia burgdorferi causes?
Lyme disease.
Lyme disease. And what's the insect?
Tick.
Tick. Okay, great. All right, good. All right, so now we also have Epstein-Barr Virus. Obviously, that's a virus. And what does it cause? Mono, infectious mononucleosis. And we also learned that the way that it's diagnosed is through a couple of laboratory tests. So that's that one. And then obviously we know what this one causes, human immunodeficiency virus, or HIV. And one of the questions that we had on the open book had to do with when do you determine when somebody moves from HIV infection to AIDS? And it was also a homework question. And so you had to fulfill one of these three conditions. The CD4 was under 200. The CD4 percentage was under 14% of the lymphocytes, or the person had one or more of the AIDS-defining illnesses. So remember Cryptococcus, okay? That's an AIDS-defining illness. And so just if the person would get a cryptococcal meningitis, then they have moved from being HIV infected into being considered an AIDS patient. So
I can't remember, did you say, are there going to be like short answer on the final?
no, it's
Okay.
all multiple choice. Yeah, it's all multiple choice. Okay. All right, so there we go. That's that. And now we're going to move on to the respiratory system. Okay, and I'm not going to read, if we've already identified the organism, I'm not going to repeat that, so in the interest of time, we're going to go kind of move on a little quicker. Streptococcus Pyogenes, of course we know it causes strep throat, and it also, there's some consequences of strep throat that we learned about, the post-streptococcal sequelae, and you need to be aware of those. Corynebacterium diphtheriae, which causes diphtheria. And so, what was the one thing that was one of the serious things, features of diphtheria? Do you remember that? Which was it was the blockage of the airway because of the membrane that forms in that diphtheria patient. And what is the organism? What is Corynebacterium?
Gram-positive bacilli.
Yes, it's a gram-positive bacilli. Okay, and then we have Bordetella pertussis. What does Bordetella cause?
Whooping cough.
Whooping cough, that's right. And what organism is that? What kind of organism is that? Got the red pen. It's a gram-negative bacilli. Okay. We had Influenza Virus. And one of the big things that we learned about Influenza Virus was how it changes, and how the more it changes, the worse the flu season is. And if it's a major, not just a little drift, but if it's a shift, then we have potential of a pandemic worldwide influenza.
The shift is the bad one, right?
Pardon me?
Shift is
The
the
worst.
bad one.
Yeah, shift is the bad one, drift is not as serious, yeah. And they do categorize them in A, B, C, and A is the worst, C's the least. Yeah, that's right. Okay, and then the other one, we had the agent of tuberculosis, which is Mycobacterium. And if you let me, I'm going to just write TB there, and you know that stands for tuberculosis. Mycobacterium tuberculosis. Grape stain's not helpful, but we did learn that this is an acid-fast bacilli. We learned, what that meant, and that's one of the ways that you actually diagnose TB is seeing the acid-fast bacilli in the sputum. And let's see if we have any more. Yep, we've got two more. Okay, and we have Streptococcus Pneumoniae. That causes pneumonia. And one of the things that was important to us was knowing the populations that were more susceptible to it. And we learned two vaccines, the Prevnar and the Pneumovax, that are used. Pneumovax for the elderly and Prevnar for the young, usually infants or very young children. So again, it causes pneumonia. And then we had another kind of oddball organism here that causes a really serious pneumonia, Legionella pneumophila. And the name of the disease is Legionnaire's disease or Legionellosis, it's probably the more scientific name. Okay, on to the GI tract. Okay, the GI tract, let's see, we already know that strep is a gram-positive cocci. This one, Legionella, it's a bacteria, but the gram stain's not helpful to the diagnosis of it. The gastrointestinal tract, and we had in it, let me get back to the beginning here, we had tons of organisms. The thing about the gastrointestinal tract is that you have lots of organisms, but it's kind of similar types of diseases. It's either severe diarrhea, gastroenteritis, food poisoning, that kind of thing. The one that's the exception, though, to all of that would be the mumps virus. And of course, that's part of the MMR, the vaccine MMR. And this next one, I want to clarify something for you, because in your notes, we had, I think that has an A on it, Enterica. Do you guys remember if that had the A on it? Because I think I left it off of there, but I'll check that and I'll correct it if that's wrong. But we had on there Salmonella typhi, because that's one way that it's designated. That's the organism that causes typhoid fever. But in your book, it clarified that it's a variety of Enterica. And so that's really the more correct way of writing it. And the VAR stands for variety. Okay, so I wanted to correct that. It shouldn't hurt you though, because if you see Salmonella typhi by itself, that is typhoid fever. And then if you see anything in between there, that it doesn't matter. Just look for Salmonella typhi, and that's typhoid fever. Okay, and that's I'm going to, in the interest of time, I'm going to just go ahead and put that up there. It's a gram-negative bacilli. A lot of these GI things are going to be gram-negative bacilli. And then you have Shigella soniae, which is dysentery. And it's not the only Shigella, but it's one of the more common that you're going to find in the United States. Okay, and then we had E. coli. You know what? Well, I'm trying to save space. We have E. coli, and we have all the subtypes that I've listed there, and it's also a gram-negative bacilli. So again, you need to learn those subtypes of Escherichia coli. Now here we have an oddball guy, which is Clostridium difficile, and we learned how this guy takes over when somebody has had quite a bit of antibiotics, and this is an anaerobic gram-positive bacilli. Okay, and right, we had Vibrio cholera, causes the disease cholera. The name of the organism has an E at the end. It's a curved, but it is a gram-negative, but it's a curved gram-negative bacilli. And the main thing we learned about Vibrio was, or cholera, was the symptoms of the profuse diarrhea that goes with cholera. We also had several organisms that cause food poisoning. We had Staphylococcus Aureus, Bacillus Cereus. Again, I'm not repeating if we've already went over their gram-stain reactions. But Bacillus cereus is a gram-positive bacilli. And we had two phases of that food poisoning. Food poisoning, let's put that, FP, food poisoning. Okay, and let me get some more here. Okay, again, we have Clostridium botulinum.
That's food poisoning too, right?
And they're food poisoning too, and we have, and I'm going to do that, and we have Clostridium perfringens, and it's food poisoning. Now, perfringens is a little different from botulinum as far as, but again, it's not as serious as botulinum is, but they're both can cause food poisoning. And we know that they're anaerobic gram-positive bacilli. So as far as anaerobes go, check. I think the only anaerobes that we have really highlighted are the Clostridia. So if you see in a question that says anaerobic gram-positive bacilli, you know it's going to be a Clostridium. But now you may have choices that all 4 of the choices are Clostridium, so that may or may not be a good hint for you. Okay, but it might be if it's food poisoning, I'm going to have all of these organisms in the list. So, and you need, the distinctive thing between botulinum and perfringen is the botulinum causes that neurological reaction where all the muscles go limp. You don't see that in perfringen food poisoning. So that could be something that could help you. Okay. Yeah, go ahead.
Do we need to leave? I don't know how Dr. Mock, it's 12:27.
Yeah, it is 12:27. I'll tell you what, we'll stop it. I'll go ahead and finish